This paper presents Aura, autonomous upskilling with retrieval-augmented agents. From the prompt, Query Agent LLM creates a query to the vector database. The vector database returns a ranked set of curriculum examples that match the intent and structure of the current user prompt, which returns multiple curriculum files based on the vector similarity. The selector agent LLM then filters the retrieved candidates, scoring them to select the most suitable set. Using all the inputs and retrieved data, the curriculum LLM synthesizes a curriculum workflow that outlines all training stages and objectives for each stage. Per stage LLM generates reward functions, domain randomization, and training configurations from the curriculum LLM description and RAG outputs. Each stage repeats this process. Files are validated against a schema that enforces structure, types, and semantics, preventing runtime GPU errors. In the training block, the abstracted LLM-generated curriculum YAML files are compiled into executable MuJoCo-MJX. Then robots are trained in parallel across thousands of simulated environments. These metrics are fed into the feedback LLM, monitoring training progression and indirectly cross-checking the other LLM outputs. Once the curriculum has been completed and a final policy is trained, it is deployed into either a high-fidelity simulator or real-world hardware. Users are encouraged to provide qualitative feedback with quantitative metrics. This evaluation, along with the full set of YAML files, is fed into the vector database. Future runs benefit from this accumulated knowledge, enabling more targeted curriculum synthesis and refinement. We compare the simulation rollout of each case using the same randomizations, disturbances, and seed. We test Aura on two use cases: blind, where it generates all the curriculum files from scratch, and tune, where Aura starts with a MuJoCo playground reward made for a different humanoid in the vector database, and improves off of it. We also evaluate Aura on the linear velocity tracking task, where both Aura methods outperform the human baseline. We tested Aura on different embodiments, such as the Berkeley humanoid. We compared it directly to MuJoCo Playground's Berkeley humanoid policy inside their environment, and we can see Aura's policy has much smoother trajectories with a more natural stepping gait, and tracks velocity commands better. A similar result can be seen on the Booster T1 humanoid, where Aura notably added multiple action penalty terms to create smoother locomotion policies. We also tested Aura on manipulator embodiments, where we tested its capability of creating policies capable of pushing a cube to its target position, and stack a cube on top of another cube. For this experiment, we allowed Aura to train longer, achieving significant disturbance rejections when stepping off the platform. The same policy was zero-shot deployed on a custom humanoid robot in the same scenario, showcasing Aura's training capability. For locomotion, the Aura-trained policy was able to walk over a slippery concrete surface at 0.18 meters per second with less than 1% of gait frequency tracking error. Aura-trained policy was tested on a dirt surface, demonstrating the policy robustness.